What's up everyone, welcome back. Patrick here, moving on to the next video dealing with piecewise functions. So in this particular video we have a couple of different graphs of piecewise functions and we have to make the equations for them. So before we were given equations, we had to make graphs. Now we're going to go in the other way. Got graphs, got to make equations. So with this first one in particular, notice that we have two pieces here. So the first piece, we got this line right here, and then we have this quadratic. Now the first thing I look for, what x value are they meeting at? Well, notice that this quadratic, this line, they are meeting at an x value of 1, right? And there's only two pieces. So I know that the domain of my piecewise function, one of the domains is going to be when x is less than 1. Now why is it less than 1? Because it's a whole right here, right? So it's not including that 1. This quadratic here, it's not going to include the 1. So it's just x is less than 1. It's going to be defined by this quadratic. And then when x is greater than or equal to 1, it's going to be defined by this line right here, right? Because there's a solid dot. It's including that 1, right? And then basically we just have to find the equations of the quadratic and of the line and then put it right there. So let's start off with the quadratic. Let's maybe do this in a different color. So notice that this quadratic, it contains this point 1 and 2. I know it's a hole on the graph, right? But if we were to pretend to extend this quadratic, then we know that the point 1 and 2 would be on the graph of this quadratic. And we're going to use that point right there to solve for the a value. Okay, I know it's a hole there, and on the piecewise function, it's not going to be defined at that x value of 1, but I am still going to use that coordinate right there, 1 and 2, to solve for the a value of this quadratic in order to get the actual equation. Because notice that we have the vertex here at -2 and 5. So what we could use is the vertex form of this quadratic, right? The vertex is -2 and 5. So I know my bracket here is going to be x plus 2 or x minus -2, which turns into x plus 2. So x plus 2 squared plus 5, like that. And then I'm going to plug in this point 1 and 2 for x and y and solve for a. Now we could have also used some other point here, but notice that it was not obvious. There was no other coordinate really given, right? It was only this 1 and 2 on the quadratic that was given in the diagram. So that is the that's the point I am going to use. So I'm going to sub in 2 for the y value. I'm going to sub in 1 for the x value. And now we just have to solve for a. So bring the 5 over. 2 minus 5 is -3. 1 plus 2 is 3, and then we're going to square that. So we'll have -3 is equal to 9a. And so notice that a is going to be -3 over 9, which is -1 over 3. And so our equation for the quadratic is basically going to be -1 over 3 x plus 2 squared plus 5, like that. Right? That is basically this piece right here that we just got. Right? We were given the vertex, so might as well use the vertex form and then just use that 1 point to solve for the a value. Okay, now what about this line over here? So the line, very simple. Notice that we're given 2 points on the line as well. This point here, we can tell is what, 1 and -1? This point right here. That is going to be 1 and -1, and then we're given this point here, 3 and -2. So if we're given 2 points of a line, we could find its slope, which is going to be y2 minus y1 over x2 minus x1, right? This is x2, y2, this is x1, y1. So from here, we would have what? -2 plus 1 over 2, which is going to be -1 over 2. So that's going to be the slope. Makes sense that it's negative because it is sloped downwards. So we have our slope, which is -1 over 2, and then we just have to plug in one of the points and get the b value. So we'll have y equals negative 1 over 2x plus b. Let's plug in the 1 and negative 1. So we'll have negative 1 for y. And we will have 1 for x plus b. This negative 1 over 2, when we bring it over, it becomes positive. That's going to be the b value. Negative 1 plus 1 over 2 gives us negative 1 over 2. So that's going to be the b value. And then it's also the slope. And so we would say negative 1 over 2x minus 1 over 2, like that. Right? And you don't put like here y equals, right? You only put the right side, let's say, of these equations of how the x value is going to be defined. And then we have our domain. So that's the piecewise function for the first graph. Now moving on to part B, we have another graph here with two different functions. Here I differentiated it with two colors. So notice that this first function here, notice that it's a V shape, and hopefully you could recognize that that's an absolute value function, right? That has undergone transformations. And then this red function here, it has this sort of curved shape, which is the square root function, right? And that's undergone transformations as well. And so we're going to have to find the equations of both of these. Now, what x value are both of these meeting at? Well, notice that they both share this point here, 2 and negative 1, right? So notice that this function is continuous. Both the absolute value, the square root function, they're going to share this point. And so they are meeting at an x value of 2. And so when we make our function, our piecewise function, we know that the domain, and actually we have a choice here. So we could say x is less than 2, and then x is greater than or equal to 2. So that's one way we could do it. We could define that x value of 2 on the radical function, but we could also say x is less than or equal to 2 and greater than 2. So then we could put the point on this absolute value function. It doesn't matter, both functions share that same point, right? And so we actually have a choice here for how to define the domain. I'll just leave it like this, right? So I'll put that x value of 2 with the absolute value. X value is less than or equal to 2. It's going to be this. And then for x values greater than 2, it's going to be this radical function. So now what we have to do is find the equations of these. So with the absolute value function, notice that its vertex is at negative 1, negative 4. So that means that the d value is negative 1. And the c value is negative 4. So we know our format for an absolute value function. Now, I'm going to actually ignore the k value because remember, you can always make equations assuming a k value of 1, right? You could always just solve for the a value as long as you have the d value and the c value. So we know that it's basically x minus d plus c. Right, that's the format right here, and then we're just assuming that there's a k value of 1 there. So we're not even going to deal with the k value this whole time. So we'll have y equals a x minus negative 1, which is x plus 1, like this, and the c value is minus 4. Now we have to solve for this a value. Well, how can we solve for it? We could plug in this point to a negative 1 for the x and the y, right? So negative 1 is equal to a 2 plus 1, and then this is going to be minus 4 like that. Bring the negative 4 over, negative 1 plus 4 gives us positive 3, equals a times the absolute value of 3, which is just positive 3. Divide both sides by 3, we get an a value of 1. Right, so the a value is going to be 1 right here. And so this, let's maybe put in a different color here, right? This function, this absolute value function, is going to be the absolute value of x plus 1 minus 4, like that, right? And the a value of 1 is in front there, but because it's just 1, we don't have to put it. All right, so that's going to be that function right there. Now, what about the square root function? Now, same thing, when we're making an equation, we don't necessarily need a k value. We could assume the k value is just going to be 1. And so the general format would be a, the square root of x minus d plus c, like that. Well, notice that the beginning point of this square root function is this 2 and negative 1. So for this square root function, this vertex right here, the d value is going to be 2, the c value is going to be negative 1. So we'll have y equals a, the square root of x minus 2 minus 1, like that. And then how are we going to solve for this a value? Well, notice we're given another point here, this x-intercept. It's going through 3 and 0. So we could plug in 3 and 0 for x and y and solve for that a value. 3 minus 2 minus 1. Bring the minus 1 over, so we'll have 1. So notice we're actually going to get an a value of 1 here as well. Square root of 1 is just 1 times a is a. So the a value is 1. Right? So here we would just plug in 1. And so the square root function is defined by x minus 2 minus 1, like that. Again, there's a value of 1 there. However, because it's 1, we don't have to put it. And that would be it, right? So that would be the piecewise function for this graph over here. And then notice that if you plug in 2, you could do a quick check. If I plug in 2 for here, for x, 2 plus 1 is 3. Absolute value of 3 is 3. Minus 4 is negative 1. Right? We get that y value, negative 1. If I plug in 2 here, 2 minus 2 is 0. Square root of 0 is 0. Minus 1, we get that same y value of negative 1. So if you want, you could do it. You can do a quick check to see that you're getting that same y value, right? And this function just ends up being continuous across the entire domain. And then finally, moving on to part C. This one's going to be a tricky one. So notice we have 2 graphs here. Again, I differentiated them with different colors. So notice that this one here on the left, it's going to be a rational function. And then this one over here, that's just going to be a straight horizontal line in red. Now, what's the meeting point of these? Notice that they're both meeting at an x value of 3, right? This one over here, the rational function, it's going to have a hole at this coordinate 3 and negative 3. And then the horizontal line, it starts with a solid dot at the coordinate 3 and 5. So we can actually set up our domain of this piecewise function. So we could say, okay, the rational function here in white, that's going to be x values less than 3, not including the 3 because this is a hole here. And then this horizontal line is going to be x is greater than or equal to 3 because it's a solid dot right there, right? It's including the 3. And then actually, very simple, horizontal line, the y values are just what? 5, right? They're staying as 5 this whole time because this point here had a y value of 5. So we know the rest of the points are going to have a y value of 5. And so to represent a horizontal line, as we've seen in videos before, we just put the y value right there. And so we're actually done this function, this horizontal line. Now what we have to do is find the equation of this rational function here. So a couple of things I'm noticing. Notice the rational function, it has a vertical asymptote at an x value of 1. It has a horizontal asymptote at a y value of negative 1 right here, right? There's a horizontal asymptote. There is the vertical asymptote. And if you remember from transformations, the vertical asymptote for a rational function is the d value, right, of 1 over x after it's transformed. And the horizontal asymptote is the c value. And so the general transformation format, again, we could assume a k value of 1. So we're only going to have to solve for an a value. All of the stretches and compressions are going to be put in the a value. So the general transformation format, in that case, without the k value, or assuming a k value of 1, it would be a x minus d plus c, like that. Well, we have the d value of 1. Right, that's going to be x minus 1. And then we have the c value of negative 1, like that. and we just have to solve for that a value. Well, how are we going to do that? We're going to plug in this point, 3 and negative 3. Now I know it's a hole there, right? So on the piecewise function, it's not going to be defined. But if you were to just look at this rational function, right? We're just getting the equation for it. That 3 and negative 3 is going to be on that rational function if we were to extend it, right? And just look at it in an abstract way. So this point 3 and negative 3, that's the point that I'm going to plug in for x and y to solve for the a value. So we'll have negative 3 equals a, 3 minus 1, minus 1, like that. Bring this minus 1 over, negative 3 plus 1, right? Changes signs. That would be negative 2 equals a over 3 minus 1 gives us 2, like that. Just give me a sec. Yeah, everything is good. So from here, I'm going to put the negative 2 over 1, cross multiply. 1 times a is a, negative 2 times 2 is negative 4, like that. And so we would put the negative 4 right there, and then that would be our function, right? So it'd be negative 4 over x minus 1 minus 1, like that. That's how the y values would be defined for that left function right there. And then that's it, right? So I just wanted to throw in some tougher ones here where you got to use your knowledge from the previous section where we went over transformations of the different parent functions, especially this one, the 1 over x, right? The d value, c value represents the vertical asymptote, horizontal asymptote, respectively. So I don't know if your teacher's going to make ones this complex. Maybe they'll make more complex ones, who knows? But this is the general process that I go through when I'm creating these equations. I first find out what are the meeting points, right? Set up my domains, and then I go into finding the equations of the respective functions. And that's a wrap for the video. Hopefully you enjoyed that. If you want to see more videos like this, please go to my website, allthingsmathematics.com. Over there, all of the videos are organized by chapter, by section. If you feel like you need tutoring at any point, you could also hit me up. My contact details are on the website. Enjoy your day, and I'll see you in the next one. Peace out.